Okay, so right now you are finishing up your mission. Okay, up at the board, I have asked a couple people to put their solutions up here. So on the right we have red and blue. Here we have green and blue. Okay. You may have some other combinations. All right. But let's talk about how you got these solutions. I'm noticing that in red and blue, the parabola is dotted, but the line is not. Tell me why.
Because in the inequality, it didn't include, like it wasn't like greater than or equal to, it was just less than.
Okay, good. So it was a strict inequality, which is why the parabola is dotted, but the line had equality with the inequality, and so we make it a solid line. Connor, do we need to fix something here?
Yeah.
What should be dotted?
The circle should be dotted.
Okay. And so, Connor, tell me about your graph. Why is it only this piece shaded?
Because the line, the only thing above it was, well, everything above it was what was shaded before.
Okay.
And for the circle, the only thing that was shaded inside the circle, so the only ones that were, I guess, saying what it was above and.
Okay. So he said inside the circle was shaded. To the left of the line was shaded. So where those two shadings overlapped was where the common solutions were. Okay, would you agree with that?
Yes.
Okay. You guys just taught yourself the lesson today. I tricked you. Okay? Here are the things that we need to remember. Strict inequalities, we have dashed lines. Inequalities with that equal sign with it, we have a solid line. Okay? My suggestion to you, and some of you were remembering this from last year, the easiest way, in my opinion, it may not be in your opinion, the easiest, but for sure the fail-safe way, pick a point not on your curve to test. If it works, that's where you shade. If it doesn't work, that is not where you shade. Okay? So those of you who had the parabola, if you tested a point inside the parabola, it did not satisfy your inequality, so you shaded outside of the parabola. Okay? The easiest point to test is 0, 0. But for that parabola, it goes through 0, 0. You can't use that point to test. Okay? As we mentioned earlier, if we have more than one inequality graphed together, which is what we're doing, then we shade where all of those solutions overlap. Okay? So some of you may want to like shade, and then darken in where the shadings overlap. I'll give you a couple other ideas as we go along. Okay? So let's talk about the different types of solutions we are going to see. Okay? We are going to see solutions that are bounded. Okay? And it's important to know that these corner points are called vertices. Those will be very important for us tomorrow when we do linear programming. Okay, here our solution is bounded, and each of those corner points we call a vertex, or plural vertices. Notice how up here these two lines intersect, but it's not where our solutions are, so it's not a vertex. How are we going to find those points? Yes, math. Yes. What kind of math? How do we find where two lines intersect? What kind of algebra? What do you say? Not the midpoint formula. What have we been doing this whole week? We've been finding where two graphs intersect. We've been finding the coordinates where two graphs intersect. Okay, so if we need to find a vertex, we need to see where those two intersect. Okay. Now, it is possible for us to have a solution that is unbounded. Notice this graph up here, how we have our shading, but it's going to keep going on forever and ever and ever. It's bounded down here by these two vertex points or vertices, but then it's going to keep growing, right? And then it is possible for us to have no solution where our shadings don't overlap at all. In this picture down here, I have a set of parallel lines where the shadings are going in opposite directions. So we don't have any common solutions. Well, I mean, you could have like a parabola and a line, or a circle and a line. I mean, there's a lot of different kinds of graphs you could have, but when the shadings aren't going to overlap, that's when you don't have a solution. Okay. So you are going to be given more than one inequality that you are going to need to graph and then shade in the common solutions. Okay. Along with that, I'm going to ask you to practice finding those vertices. Okay. Really, finding the vertices is going to be more of the algebra stuff that we do. And then, you know, graphing the inequalities will probably take, you know, less time. Okay. So I realize that we're like getting close to lunch, so we're probably going to have to start this problem and then finish it when we get back. But we might as well begin. Go ahead and write down this system of inequalities. Okay. If it helps, you can write these as equations to graph. Okay. I'm going to use red. No. Green. We're going to use green. X squared plus y squared equals 25. What does that look like? A circle with center at the origin and a radius of 5. Oh, is it a solid line? That's, or a solid curve. That's good because I drew it a solid curve. Okay, if you notice what I did with Connor's, okay, if you accidentally draw it not dotted and it should be dotted, just use your eraser and erase little pieces so it looks dotted. Okay, now are we going to shade inside or outside? Inside. If we pick a test point, easiest one is 0, 0. When I plug in 0, 0, is 0 less than or equal to 25? Yes. You betcha. Okay, so let's see. So I'm going to shade inside. Okay. Now, let's see. We'll do glue. Okay. So 4x minus 3y equals 0. That is a line. You don't always have to put your lines into slope-intercept form. I think this may be a good time to do that though. 4x equals 3y. Y is 4/3 x. So we have a line with a y-intercept of 0, 0, and a slope of 4/3. So 1, 2, 3, 4, 1, 2, 3. 1, 2, 3, 4, 1, 2, 3. Okay. Real quick, let's pick a test point. 0, 0 is not a good test point. What about 2, 0? If we plug in 2, 0 is 4 times 2 minus 3 times 0 less than 0. It is not. So we are going to shade on the other side of 2, 0 since 2, 0 doesn't work. Oh, this did not work out the way. Okay. Usually when I overlap two highlighting colors, it turns another color right here.
You can just like choose a darker.
Yep. Going to. So our common solution is here. I know. I'll remember that for next time. Use pink and green and you'll get black. Okay. After lunch we'll finish it.
But when you change it into
so we graphed each of the inequalities, and here in black is where they overlap. So if you want to wait and just color that in last, or if you want to shade really lightly, and then here where I have black, you shade really dark, or if you want to grab a highlighter and shade it with your highlighter, whatever you want to do is fine. I just need to be able to tell that that is your solution. Okay? If I can't tell the difference between this shading, and this shading, I'm not going to be able to know what your answer really is. Okay? But I'm not going to be upset if you have really light shading right here and then you darken it in right here. Okay? Now, how many vertices do we have? We have 2. We have intersection points here and here. Okay? We need to find them. How do we find where a circle and a line intersect? Yes, we use math. Okay, so I'm always going to tell you that you should use algebra. More specifically, we're going to solve a system of equations, okay? So rewrite them as equations, and you're going to find where they intersect. Okay? Elimination or substitution? We have to do substitution. And we've already solved for y. Y equals 4/3 x. Okay? So we're going to go ahead and substitute that into our circle equation. So we have x squared plus our new y squared equals 25. So x squared plus 16/9 x squared equals 25. What happens when we take x squared and we add 16/9 x squared?
25/36 squared.
We get 25/9 x squared.
I see.
And when we divide by 25/9, we get 9, right? So x is plus or minus 3. So our vertices, if we plug in 3 to y equals 4/3 x, our y value is 4. If we plug in -3 to y equals 4/3 x, our y value is -4. Now, Darby, you said a few minutes ago, can we just look and say, oh, it looks like this coordinate? Okay? Here's my warning to you. If you graph something and you think that you can tell what the intersection is, how do you know if you're right or not?
You can check it.
You can check it. So if you thought, because you've already done the work for the graph, if you thought that, you know what, my circle is really bad. I mean, it's not really bad, but it wasn't a perfect circle. But if you think that the coordinate is 3, 4, you better plug it into this one and this one to check. Okay? Because there's a chance it could be 3.1, 3.9, where it's close to 3, 4, but not exactly 3, 4. Okay? If you think it's a coordinate after you've done the graph and it checks out for both of them, that's fine, write it down. But if you think it's a coordinate and it does not check out for the two equations, you're going to have to use algebra. But since we've already done the work for the graph, and it's a nice coordinate that you can see graphically and it checks out, I'm okay with you using the graph to help you. Okay? But you have to check it with both equations. Is this process, has it been refreshed from last year? Okay. The most important part of this assignment, well, it's all very important, okay? But to help us for tomorrow, what we do tomorrow, our word problems are going to be a lot more important than they were last year. Because our word problems, we're going to use those for what we do tomorrow. Okay? Everything that we do today is setting us up for linear programming tomorrow, which you don't know what that is, but I'll tell you about it tomorrow. Okay? So I want you to take a minute and just read through this information. Don't write it all down. You can jot notes down, but don't write down those sentences. Just read through it, get an idea of what's happening here. What are our unknowns?
How many cups of each drink?
Okay, we have two kinds of drinks, right? So we want to know the number of cups for drink X and the number of cups for drink Y. Okay? So we need to set up some inequalities here. Our diet needs to provide 300 calories. How many calories are in drink X? 60. And how many calories are in drink Y? Okay, so 60 calories times the number of cups X plus 60 calories times the number of cups Y need to be what compared to 300? Greater than or equal to. We need to have 300 calories in our diet or more to be considered healthy for this. Okay. All right. We need 36 units of vitamin A. So let's pick out all of the pieces of information that concerns vitamin A. So how much vitamin A is in X? So 12X plus how much is in Y? 6Y, and that needs to be
36.
greater than or equal to 36. And then we also need to have 90 units of vitamin C. So how many units of vitamin C are in drink X? And how many in Y? And that needs to be greater than or equal to 90. We actually have two more inequalities that we need to write. And this is something that we assume and that seems very logical to us, but we still have to write it down. Can we have a negative number of drinks? We cannot. And so we need to still put that X is greater than or equal to 0 and Y is greater than or equal to 0. Now we get to graph this. Are you ready? Okay, so X is greater than or equal to 0 just means everything to the right of the y-axis. And Y is greater than or equal to 0 just means everything above the x-axis. So these two constraints right here, those two inequalities, are limiting us to where on our coordinate plane. Okay, this is just telling us quadrant 1. Okay. Now, I don't think that you should waste your time putting each of these in slope-intercept form. Let me remind you how to graph by lines by using the intercept method. How do we find an x-intercept? Put a 0 in for y. Very good. So, I'll graph this one in blue here. If we plug a 0 in for y, we have 60x equals 300. If 60x equals 300, what is x? 5. And to get a y-intercept, we can plug 0 in for x. If we plug 0 in for x, we have 60y equals 300. What is y? Are we shading towards or away from 0, 0? We are shading away. Okay. Good? All right, now we'll do this one in, we'll do green. Okay? If we plug a 0 in for x, what is our y-intercept? 6y equals 36.
Equals 6.
Y equals 6. And if we plug a 0 in for y, we have 12x equals 36. What's our x-intercept?
3.
Isn't that way nicer to graph than putting it in slope-intercept form? All right. Are we going to shade towards or away from 0, 0?
Away.
Away from 0, 0. Okay. And last but not least, we have this 10x plus 30y equals 90. Okay? We plug 0 in for x. What is our y-intercept? 3. 30y equals 90. Our y-intercept is 3. And if we plug 0 in for y, 10x equals 90. Our x-intercept is 9. Way over here. Okay. And which way are we going to shade? Towards 0, 0 or away from 0, 0?
Away.
Away. If we plug in 0, it is not bigger than 90. So I'm going to shade. Okay. So we have an unbounded solution set here. How many vertex points are there? How many corners do we have? You have 20 seconds to talk about it with your group. How many corners are there?
There's the one where it hits the y axis and the one where it hits the x axis. So there's two right there.
All right, pod 6, how many do you think there are? 3. Pod 6 says 3. Do you agree? No? How many do you say? You said 4? Okay, well, let's see. Here's my shaded. Right here, I think we have a corner. If I follow it along, right here, we have a corner. Right here, where these two intersect, we have a corner. And right here, we have a corner. There are 4. So we're going to have to identify these. Okay, let's start with the easy one. This one we know is 9, 0. And this one right here, we know that is 0, 6. Okay. Now here is where we can use algebra, or if you have a nice graph, we may be able to use the graph to figure out our intersection points. Okay? This is the intersection between the red and the blue line. It looks kind of like it's 3, 2. Okay? If you think that it is 3, 2, then let's check it. Here is red and here is blue. 60 times 3 plus 60 times 2. What is it? 300. What about 10 times 3 plus 30 times 2? That is 90? Okay. So since I graphed it pretty nicely, it looks pretty reasonable. That was 3, 2. We checked it in the two equations, and they satisfied the equation, not the inequality, the equation. That's 5. Okay. Now my other one, I'm not so sure about. Okay. My lines may not be straight, or that might not be a nice coordinate. I don't know. So this is the intersection between the green and the blue, correct? So we need to take the green and blue. So 60x plus 60y equals 300. 12x plus 6y equals 36. Okay? At your pod, I want you to work on that intersection point. So use substitution or elimination to find where those two intersect.
I know, I was like, what?
Yeah, a negative answer would not make sense. Unfortunately. And what one? Is X one?
I like the Y plus four.
Okay.
Maybe.
Okay, so 300 plus negative 360.
Ooh,
Oh.
let's go.
And 60 plus negative 120 would be negative 60. Or positive. Yeah, negative 60. Did you make it look at the right option? Oh, this is 60Y.
Okay. The first ingredient is happiness, and going back and smiles. How do you have that?
But you can where
And if there's other ways backwards, it's not basic, that's just, that triggers me. Maybe it's like a.
I'm seeing a lot of 1-4. You do?
Oh, we agree with that.
No. All right. So now up here, I color coded everything. And so I knew that I had the green and the blue line to find the intersection. If you have more than one line, like if you have 3 lines, it may be a good idea to label them. Like if you write, okay, this is 12x plus 6y equals 36. And this line is 10x plus 30y equals 90. Maybe a good idea to label your lines since you're using pencil so that you know which lines you need to find the intersection of, okay? It would not have been good to find the intersection of my red and green line. That was not a vertex, okay? So it's important to know which lines you need to find the intersection of, okay? All right, so you have on your gold sheet your assignment. It is not a long assignment. You have 1, 2, 3, 4, 5, 6, 7 problems. If you're looking at required problems, it's 5. Okay? The first few are going to be just here's equations, make the graphs, find the vertices. The last few are going to be word problems. You have to do the word problems because you need to be ready for tomorrow for linear programming. Okay?